So basically what we're looking at here is it says determine the empirical formula of a compound that contains, and then you have all these percentages, right? And so what we're going to do is we're going to start with, and then I kind of gave this generic little version of how we would write it because we don't know what those subscripts are yet, right? So we have C, we have H, and we have O. So carbon, hydrogen, and oxygen. And the percents that were given to us was that 52.11%, that 13.14%, which that is not a 14, but you know what I meant. 0.14. All right. And then we have our oxygen, which was 34.75. Okay. So looking over here, these were the different steps that we were taking yesterday. And so what you're going to do is we're going to start with the yellow step. So says assume 100-gram sample. So all that meant for us was that we're going to take these percents. We're going to say, okay, well, if I have 100 grams and that percent is the grams. So we would scribble these out and change out with a G, saying that they're now grams. So we finished the yellow step. We're going to go to the blue step, convert grams to moles. So we're going to set up a T-chart. Okay, remember we bring the words down to the right. We're going to convert into moles. So the big idea yesterday that we saw was this is always going to be a 1. This is going to be our molar mass. So looking at the periodic table, carbon is 12.011. And I kind of told you guys, make sure you do the different steps vertically, right? So we've done all of the yellows. Now we're going to do all the blues. So we're going to go ahead and fill out all of these little T-charts. Just like in your assignment on Schoology, you're going to be filling out the little boxes, right? So once again, we're going to bring grams down to the right. We're going to put moles on top. We put the 1 with mole, and this is going to be our molar mass. So the molar mass of hydrogen from the periodic table is 1.008. And then for oxygen, we're going to do the same thing. We're going to bring grams down to the right, 15.999. And again, these are coming straight from that periodic table. So 15.999, 1.008, okay? So, and then 1 mole on top. So now we're going to plug those into the calculator. So we've now done this whole column. We're going to get those answers of moles, okay? So looking here, I have 52.11 times 1 divided by 12.011. And I have 4.338. So I'm going to go ahead and round that to 4.34 moles. Then we're going to do hydrogen next. So 13.14, we're going to divide it by that 1.008. So we get 13.03. So I'm going to go ahead and round that to be 13.04. Sorry. I'm going to 2 decimal places right now. And then we have our last one for oxygen, and we have 34.75 divided by 15.999. We're going to go ahead and get it to 2.17 moles. All right, so we've now finished our blue step right here where we converted everything to moles. So that next step, the green step, is we have to divide them all by the smallest value. So here we have the 2.17, that is for oxygen. So basically what we're doing is we are comparing everybody to oxygen because we have the least amount of oxygen in this compound. So we're going to get a 1 mole for him, right? So everything is going to be a ratio compared to oxygen. So we're going to divide all of these values by the smallest. Okay. We're going to pull out our calculator. We're going to do the same thing. So we got 4.34 divided by 2.17, and we get 2. I'm going to go ahead and put a 2 there. Then we had our 13.04 divided by 2.17. We get 6.009. So we have a 6. And then for this one, 2.17 divided by itself is going to be a 1. So we've now finished the green step. So we're going to move into the red step. None of these have a 0.5, so we're good to go. We're just going to use those numbers as the subscripts. So what we end up with is we're going to have C2H6O. Okay, and that right there was the empirical formula. So that's what we covered yesterday. So you guys need to do yesterday's assignment, I think. I'm pretty sure. Yes, we still need to do yesterday's assignment, all of you. So that's what we're doing, okay? All right. So I'm going to go ahead and go to the next slide. So this is the Jamboard link that was shared, by the way, on your little Schoology page. It's up here at the top. So you can always go back to that. And I'm on slide 13, just so you guys know, okay? All right, so I'm going to go ahead and go to slide 14. And now we're going to take this one step further. So I now found out that we have C2H6O, right? That's our empirical formula that we just found. So today's goal is we're now going to find this molecular formula. So if you remember back, an empirical formula was the simplest, right? So empirical formula means it was simplified. All right. It's like a summarized version. It's basically the lowest numbers in their ratio. All right. Whereas the molecular formula is known as the true formula, or it doesn't have to be reduced. So we could have multiples of the same number. Okay. So what we're looking at here is we have this empirical formula, right? So 2 carbons, 6 hydrogens, 1 oxygen. This problem right here is the molecular formula problem. It says if the molar mass is 184.1 grams, what is the molecular formula, right? Well, then that means that this molar mass is talking about the actual true formula. So this right here, this is going to be our molecular formula mass. Okay. Over here, we have the empirical formula. So we do need to know what is the empirical formula mass. And that's going to be the step that you start with. So once you have an empirical formula, the first thing that you do with it is you got to find the mass. So what we're going to do is we're going to refer to our periodic table. So once again, carbon is 12.011. Hydrogen is 1.008. Oxygen is 15.999. So we're going to go ahead and add together 2 times that 12.011 plus 6 times the 1.008 plus 1 of the oxygens, 15.999. Okay. When I add those together in the calculator, okay, 2 times so there's our carbon plus, now we have our 6 times 1.008 plus 15.999. So when I add all those values together, like you see right here, we end up getting a 46.069. And that is grams per mole. All right. So this right here, this is the empirical formula mass, right? So this is the empirical formula mass. This is your molecular formula mass. So as you can see, this is the smaller number. So the actual formula that we're going to use in order to calculate these things is going to be similar to what we did with when we were trying to find the empirical formula, right? We had to divide all of them by the smallest because you want that ratio to the smallest amount, right? Side note, your molecular formula, if this number was also 46.069, then yay, they are the same thing. Empirical formula is your molecular formula, all right? For this one, we see that we have a bigger number and a smaller number. So that means that we got to divide it to figure out what is that ratio. So I'm going to go ahead and take the kind of what we're going to be doing is molecular formula mass. We're going to divide it by our empirical formula mass in order to figure out what is that ratio. All right. Once we have that ratio, we're going to take that and we're going to apply it to all of these subscripts, right? So we're going to take that ratio and we're going to apply it to all these subscripts in order to figure out what all of them needed to be multiplied in order to find that true formula. So that's going to be what we're going to be doing. So molecular formula mass divided by empirical formula mass. So what we have here was we had our 184. So I'm going to go ahead and write it down here. So I had my 184.1 divided by my 46.069. I'm going to plug those into the calculator. And we get 3.996, right? 3.996, which means that's approximately 4. So 4 is my number that's going to go in for the ratio. So it's going to be a 4. Okay. And so now this 4, I'm going to multiply by all of the subscripts that we have. So we end up having 4 times 2. So that would be C8, 4 times 6, H24, and 4 times 1, O4. That is your molecular formula. So today's is a lot easier than what you had to do yesterday. Yesterday, you needed to kind of write out as much as you can, but use the videos and use our example that we just started with. I'll get it posted into the updates here soon. And that's kind of it. So I would just use today to double check things. Enjoy your weekend. Be ready to go on Monday because we have a test on Tuesday. All right. Thank you guys so much for coming. You can stay on.